Hello friends, let us know how to divide a given line segment in a certain ratio internally. This kind of construction can be done in two different methods. One method is already discussed in the previous video. Let us see the other method of dividing a given line segment internally in a certain ratio. Let us consider the example question that I have written. So we have to divide a line segment of length 7.6 centimeter internally in the ratio 5:8. So I'll draw a line segment using the ruler of length 7.6 centimeter. Once we do so, at one of the ends of this line segment, which we will label as AB, at one of the ends, we will draw an acute ray. So at one of the ends, I have set the ruler and we will draw an acute ray. Before that, let me extend the length of the line segment. Right. So at one of the end, the ruler back and name the line segment. So the given line segment be AB. So the name of the line segment AB, and we have drawn at A an acute ray AX. So AX is divide the line segment AB in 5:8 ratio. Now this ratio numbers are very crucial. So the ratio is 5:8. So the step 3 of the construction is we have to add the ratio numbers, that is 5 plus 8, which is a 13. And on this acute ray AX, we have to draw or mark 13 equal divisions. So for doing so, let us have a circular or a compass with which we will mark 13 equal divisions. So I have taken the compass, and the compass will be set at a certain radius. It can be anything. So based on the page length of your notebooks, you can do that. So placing the we have to mark 13. Whatever is the ratio numbers have to be added. And on adding what number we get, that many equal number of divisions we have to cut on the acute ray. So that's the second arc. The third, the fourth, the fifth, it's going to be too long, fifth, sixth is done. So this is the eighth division, 5 more, 8. So this is a 9, then 10, then 11, then 12, and the last arc 12 and 13. Okay, and let's send this circular back, and I just extend the line segment a bit so that the 13th arc point of intersection with the acute ray can be clearly seen, and that's it. So we can see all the 13 equal divisions. Now let us name these equal arcs. So now what next we have to do is the ratio. We have to divide AB line segment AB in a 5:8 ratio. So the sum is a 13. So 13th division we have to join to the other end of line segment AB, that is point B. So at one end, so 13 is the sum total. So 13 equal number of divisions. 13th division is joined to the other end of line segment AB. At one end acute ray, another end connected to 13th division. Now the ratio numbers are 5:8. The first number is 5. So the total number participates, and in the ratio number the first number participates, that 5. So at fifth division, we have to draw a line parallel to the joined line. And how to draw the parallel line? For drawing parallel line, we have to construct the equal corresponding angles. So at A13, and I can have some radius. It's okay, whatever be the radius. Actually, at A13, I will place a pointer and draw an arc of certain radius and measure what is the angle here. Right. I place the circular pointer here and I have stretched to what length? That one verification once I do. So that with the same radius, with what radius I have drawn an arc here, this is a 12 centimeter that you can see. And if you're not able to see, I place a magnifier and I'll show you what is the length. Where is the magnifier? Yeah. Now see 12 centimeter. So with a 12 centimeter radius, I have to draw an arc placing the pointer at fifth division. So this is the procedure. So I place the circular pointer at A5 and turn the circular and have to draw an arc intersecting the acute ray. That's more important, intersecting the acute ray. And then we have to measure what is the angle, the circular between these 2 points, and this is the minimum number I see. Minimum number, that is the minimum number on the circular that comes is 2.6. It appears a bit less than 2.6. Okay, so we will take our and turn, and it should be the smallest. 2.6 is smallest. We will go for a bit lesser than 2.6. So I'll place the circular, but cutting arc, if I cut arc, it becomes of 2.6 centimeters. So 2.6 is very small, but that was less than 2.6. So what I, where the arc with the center A5 I have drawn. So I have to place a pointer here, but this time I'll just take the pointer a bit down because that much variation was there. And then just rotating this circular, I just cut an arc and let's send it back. Now take the ruler and join the point of intersection of the 2 arcs that I have drawn just now and point A5. So I place the scale between the 2 point of intersection of the arc above and below A5. So we have to join these two. I'll use procedure, and this construction is quite long enough. So I just zoom. The parallel line intersects line segment AB. So I just take a thicker pen, and this point is C. So point C divides AB in 5:8 ratio. So you see, we have done the construction BA13. A13 is here in this location. This last arc is A13. I just placed a dot there. We get the point C on AB that divides AB in 5:8 ratio. How do we do the justification? For the construction, we have a B A13 parallel to C A5. Then in triangle A A13B, we will apply a basic proportionality theorem. By basic proportionality theorem, parallel to one side, so we already have the parallel lines, then the other 2 sides are divided in the same ratio. So AA5 divided by A5 A13 must be equal to AC by CB, and this is a basic proportionality theorem. And now A to A5 is 5 division, A5 to A13 is 8 equal division. Hence we have AC by CB is a 5 by 8. Therefore point C divides line segment AB in 5:8 ratio.